Good afternoon. Today is Monday, October the 5th. In pre-calculus today, we looked at logarithmic functions. They're the inverses of the exponential functions that we looked at the last part of last week. So I'll share my screen here and show you some of the things we talked about with the logarithmic functions today. Now, if we draw our axis here, we can look at what happens with a logarithmic function. If you remember, with the exponential function, we always looked at y equals something like 2 to the x. We looked at the 3 points for x, which were -1, 0, and 1. And remember, for anything to the 0 power is 1, so we always get a 1 here. For the 1, we always have the base, which in this case is 2. And then for -1, we get 1 over the base, which would have been 1/2. Now, so if the log function, the corresponding log function is y equals, so let's go ahead, we'll go ahead and draw the exponential function through about right like this. So this point right here was 0 and 1. Now, for the logarithmic function, it's equal to, we would say log base 2 of x. And since these two are inverses of each other, if we come down here and look at the x and the y, remember, when we have inverses and we go from a function to its inverse, the coordinates swap. So in this case, we would have the 1/2 here for the x and the corresponding -1 for the y. The 1 would go for the x and it would correspond to 0. And the 2 would go for the x and it would correspond to 1. So what you're looking at is you're coming up off of the y-axis here as an asymptote, and you're coming through like this. So this point here now would be the coordinate 1 and 0, because that is exactly the opposite of the coordinate that was up here at 0, 1 for the exponential function. Now, so if you look at the exponential function, your domain was all reals, and your range was y greater than 0. Now, so since the logarithmic function is the reciprocal, or not the reciprocal, but the inverse of the exponential function, not only do the coordinates swap, but the domain and range swap. So the range for the logarithmic function now is all reals. And the domain is x greater than 0. Now you have a couple of situations when you're looking at logarithmic functions. Basically, a log is an exponent. So if I have, for instance, if I have log base 2 of 16, I'm asking myself the question, okay, what power to erase 2 to get 16, and the answer is 4. So log base 2 of 16 is 4. Similarly, if I do log base 3 of 27, I'm asking what power to erase 3 to get 27, and the answer is, of course, 3, because 3 cubed is 27. Okay, now you have a couple of other kind of standard situations. If I have log base 2 or log base anything, if the base, like if I have log base 2 of 2 to the x, since that 2 and that 2 are the same, my answer is x. If I have log base 2 of 1, then the answer there is 0, because anything to the 0 power is 1. Okay. Now, so those are some standard relationships that exist in logarithms. If you glance through the section in your book in chapter 3, if you glance through the section there, looking at the logarithms, kind of read through that. If you have any questions about any of the things that you're reading, if you'd send me an email, and I'll be glad to get back with you. Tomorrow we'll look at some more of this. We'll look at some further problems in this section. So you can look at your homework for that also and send me a question if you have any questions.